on operating system OS and how it works. So, an operating system OS is a program that, after being initially loaded into the computer by a boot program, manages all of the other application programs in a computer. The application programs make use of the operating system by making requests for services through a defined application program interface (API). In addition, users can interact directly with the operating system through a user interface such as command line interface (CLI) or graphical user interface (GUI). So, why use an operating system? An operating system brings powerful benefits to computer software and software development. Without an operating system, every application would need to include its own UI, as well as comprehensive code needed to handle all low-level functionality of the underlying computer, such as disk storage, network interfaces, and so on. Considering the vast array of underlying hardware available, this would lastly blot on the size of every application and make software development impractical. Instead, make many common tasks such as sending a network packet or displaying text on a standard output device, such as the display, can be offloaded to a system software that serves as an intermediary between the applications and the hardware. The system software provides a consistent and repeatable way for applications to interact with the hardware without the application needing to know any details about the hardware. Instead, many common tasks such as sending, so as long as each application accesses the same resources and services in the same way that system software, the operating system can service almost any number of applications. This vastly reduces the amount of time and coding required to develop and debug an application, while ensuring that users can control, configure, and manage the system hardware through a common and well understood interface. So, once installed, the operating system relies on the vast library of device drivers to tailor OS services to the specific hardware environment. Thus, every application may make a command call to a storage device, but the OS receives that call and uses the corresponding driver to translate the call into actions commands needed for the underlying hardware on the specific computer. Today, the operating system provides a comprehensive platform that identifies, configures, and manages a range of hardware, including processors, memory devices, and memory management chipsets, storage, networking, post communication such as video graphics array (VGA), high definition multimedia (HDMI), and universal serial bus (USB), and system buses interfaces such as peripheral component interconnected bus (PCI). What are functions of an operating system? An operating system provides three essential capabilities. It offers a UI through a CLI, command line interface, or GUI, graphical user interface. It launches and manages the application execution, and it defines the exposes system hardware resources to those applications, typically through a standard API application. पता नहीं क्या. So UI, every operating system requires a UI, which is user interface, enabling users and administrators to interact with the OS in order to set up, configure, and even troubleshoot the operating system and its underlying hardware. There are two primary types of UI available: CLI and GUI. The CLI, or terminal mode window, provides a text-based interface where users rely on the traditional keyboard to enter specific commands, parameters, and arguments related to specific tasks. The GUI, or desktop, provides a visual interface based on icons and symbols where users rely on gestures delivered by human interface devices such as touchpads, touchscreens, and mouse devices. The GUI is most frequently used by casual or end users. They are primarily interested in manipulating files and applications, such as double-clicking a file icon to open the file in its default application. The CLI remains popular among advanced users and system administrators that must handle a series of highly granular and repetitive commands on a regular basis, such as creating and running scripts to set up new personal computer PCs for employers or the employees. Application management. An operating system handles the launch and management of every application. This typically supports an array of behaviors, including time sharing, multiple processes, or threads, so that various tasks can share the available processes time. Handling interruptions that applications produce to gain a processor's immediate attention, ensuring there is enough memory to execute the application and its corresponding data without interfering with other processes. carrying out error handling that can gracefully remove an application's process